Welcome all in this video lecture series. In this video lecture, we are going to see what is the fractional knapsack problem. And then we will try to apply the backtracking approach. We will see the solutions if there are more than one, and from that we will do the pattern analysis, and then we will try to see that how the greedy method that is actually useful to solve this problem somehow relate with the backtracking. So now this video is a link between the greedy and the backtracking strategy, that from one technique how to go to the other technique. So let's try to use the fractional knapsack problem. We have given three items. We have a back capacity of 12 kg. Now of course we are not going to take all the items. If we take all the items, our capacity is 12 kg, the bag will be tear down and there is no use to continue. So that's why can take the items. Now in one of the other video series, we have look out at the 0-1 knapsack problem. Well, in the 0-1 knapsack problem, you can take the item or you can leave the item. While in the fractional knapsack problem, either you can take the item, you can leave the item, but if you take the item, there are two choices. Either you can take the item entirely or you can take the fractional of that item. It's like, consider that I am going to buy certain items, let's say vegetables in the markets. Now consider my bag capacity of becomes 11 kg. Now only 1 kg available, so of course I can only buy even though they have let's say one particular vegetable available in more amount of quantity, I do not have to buy all the quantity. I will buy only the 1 kg because my bag now handle 1 kg. So that you can see that according to what we have, we can take the items. That is the unique advantage of using the fractional knapsack problem compared to the 0-1 knapsack problem. So that's why in our real time fractional knapsack is also useful. In certain more applications 0-1 knapsack is also useful. So that is the way of use it. So let's continue. First of all, why we use the backtrack. Of course, in all the video that I will try to exploit the backtrack, so that if someone will try to look at the particular video, still they will get a sense that why this types of video is designed, that will try to integrate the two techniques of algorithms and try to showcase the bridge between these two techniques. So of course, why to use the backtracking? Well, we have already the greedy algorithm available for the fractional knapsacks. Even you can see that while we studying the greedy algorithm, we have seen the fractional knapsack, and that will take n log n times because we require the sorting. That's why it will take n log n for the sorting, and after sorting that will take of n time, that we only require one while loop and it will be continue. That is what it will do. So if we have already a greedy approach, why we use the backtracking? Well, the thing is, maybe when the problem will be first came out, we don't know whether greedy is useful or not. So in that case, we can try the backtracking because it will give all possible solutions, because it can be applicable to all the problems also backtracking. So first we apply the backtracking, we get all the possible solutions. From the solutions, we will try to see is there any pattern available. If yeah, there is a pattern available, then we will try to get our answers. That is what the backtracking do. Yeah? So now only the problem with backtracking is that if you try with a minor examples, it is quite good to understand, to get it through. But if you take much more examples, bigger examples, it is become much more complex. And that is the problem, because you don't have enough time, you don't have enough resources, also the space. So that's why backtracking has an advantage and disadvantage both. So this particular video will showcase the use of backtracking. Yeah? So first we get our problem, then for that instance we will solve using the backtracking, and from that solution we will determine that yeah, actually we are doing a greedy here. So that's what we'll do in this particular video lecture series. So it is similar to our pattern analysis. That's we will do. What we do in pattern analysis in the research, that kind of, let's say we have one problem. For that problem we will see that how many solutions we have. We will try to get the patterns. Once we have a patterns, we will use the pattern recognition algorithms or any other techniques, and from that things we will get to know which pattern is possible to solve not only this problem, the other problems too. So that is what the unique advantage, and that similar advantage we will try to resort here, because backtracking will give me all possible solutions of a given problem in algorithms. That's what is a best fit, and we will try to use the not a simple method of backtracking but somewhat intelligent with the feasibility options. So in a example I will tell you how this feasibility will be maintained and how to avoid unnecessary depth that is not required in the backtracking. Because if you follow the backtracking blindly, again you are making your algorithm much more complex. So that's why you have to resort to the intelligent method. So consider this particular state space tree that I have prepared for the following example. If you want to understand what do you mean by state space tree, I have designed another video for this space tree devoted to the state space tree in terms of backtracking, that you will try to look at it out. Consider this is the legend, that is profit and the weight. So for each particular state, this all the rounds is we call the state, and all the edges, that is the positions. So from one state we will take one particular positions, and then we will move to the other state, and we continue in that way. So let's try to understand. We will start with empty. Why empty? Because every problem has a solutions. That's what algorithm tells. So that's why here in this particular problem we have solution available, but we start with an empty bag. It's like I'm going to buy a certain item from a market, but while I'm going from my home to the market, my bag is empty. When I came back from market to home, maybe my bag is full or partially full. But when I'm going to market, my bag is purely empty, because I know that I have a certain items available in my bag, because I have certain answer available in my bag. So in similar way, here we have solution available. Now we first explore the first item. Yes, we will take the first item. Second item, yes, we will take the second items because it will satisfy feasibility criteria. Now my bag is full. I don't have to rethink about the third item. That's why I stop here. So in this way, this one is an intelligent approach. That's it won't try to go in further deep to check out, because the moment I know there's no need to go further, I have to stop there. Again I will backtrack, and then again I will go to the third. Yes, can I take the item third? Well, I cannot take the item third entirely, but yes, I can take the partial item. If I take the item partial, I'll get the profit partial also. That is what it will tells. Well, 10 kg already I have used, the only remaining 2 kg. So from item third, if I take the 2 kg of weight, then in the value also my profit will become reduced. So that's why in place of 6, I will get the 4. So profit will be 14, weight will be 12. Now again my bag is full. Well, I don't have to go into more details in the depth. Again I will backtrack. Again I will backtrack here, and I will check out, do I have any other child available? Yes, one is explored. Now I have to go with the second, because there are 3 items, so there are 3 child to this route. If there are n items, then there are n child of the first particular node. So yes, I will go to 2. The profit is 5 and 2 weight. Again I will go to the particular next item 1. Well, I have taken the item, my total weight become 12. I don't have to go further down here. I will stop from here. Again I will backtrack, so and so on. Again I will try the next item. Well, yet my bag is not full. Whoa, I will go to the next item 1. Wow, that's a good thing. I will take it here. Yeah. Number 3 and the 1. Yep, I can take the 1, not entirely, but the partial I can take it. So again after once my bag is full and yet no any items available. So 3, again I will take the 2. Now 1 and 3 both is explored, so I don't have any other child to get explored. So now I will come back to the here, then I will come back here, and then I will try again the 1. Well, my bag is full, so I will stop from here. I will again backtrack here, then I will go to the 2. Yeah, 2, that is possible. Again, can I take the 1? Yes, I will take the 1. Then I will take the 1. and similar I will take the one here, and then once there is no any child I will stop here. So clear? So this is the total entire tracing of how the backtracking depth first search is calling here, how this graph will actually prepare. This is the way it will be prepared. So now the total answer I can see here that there are two nodes that will give me this answers, this particular and this particular. So there are this particular two items that will give me the answer. Now I have to check out, is there any pattern in these two solutions? One solution is 2 3 1 while the second solution is 3 2 1. That is the things that I have to check it out. Yes, now if I see the 2 3 1, that will be the value by weight ratio. Okay, because here if I take it 10 by 10 it is 1, 5 by 2 it is 2.5, and the 6 by 3 that is a 2. So value by ratio of 2 is highest, then the 3, then the 1. So 2 3 1. So this particular approach will exploit the use of a greedy. Whoa, the moment you got it VW, we can use it straight away. That is our greedy approach, and we know that in the greedy we have to follow a certain greedy criteria, that is a strategy, and here our strategy is V by W. The item having the highest V by W, we will take it first, then the lesser V by W, then this go and slow and slow on. So that's why now you can see that the linkage between the greedy and the backtracking using this example. First we get the examples, we don't know which technique is possible, then we try the state space tree, then we will get to know that okay, there are more than one solutions. In one of the solutions we try to identify the patterns, and we are lucky that we got the patterns and that follow the greedy criteria. So that's why we can use the greedy methods in this case, and that is successful. So now this video will try to tell you the breach between the backtracking and the greedy methods. So you can refer the books as per the syllabus mentioned. You can refer the NPTEL videos to understand what you mean by fractional knapsack, what you mean by backtracking, that you can go into details. Also you can refer my other videos to understand what is the backtracking as well as the state space tree, that you can go on. I hope that from this video you will get to know the link between the greedy and backtracking and how to come from one method to another methods. That is. Thank you for watching this video.